All right. So yesterday we talked a lot. Well, we talked on the main process and the main ideas of when performing a design study and a concept analysis. And today we want to see the features, especially on the components module. How can you perform that, and how you start designing your system directly in Valispace. As a reminder, on the last webinar last month, we talked a lot about the requirements itself and the specifications. Yesterday, we also talked briefly about the user needs or the customer needs and stakeholder needs. So in Valispace, as we saw at the last webinar, you will have all your requirements there. And later on, we will make that traceability and doing all the verification. And this is the topic for the following webinar. So today we will focus mostly on the components module. And I don't know how much of you already used our Valispace or not, so I will go initially through the basics of the main ideas of Valispace, of the components module, and go a little bit on the features for the trade studies and concepts. Okay, so here in the components module, we have on the sidebar, we have this structure tree, which contains the components. The components here represents each element of your system. It can be either hardware, a main subsystem, or a software element. It can be also conceptual elements of your system. So for example, operations, a mission, um, any other concept. For example, for satellites, you can have the orbit and so on. So you have, it doesn't need to be a physical element. You can have components as generic as you want. And for each component, we have here the properties of the components, what we call the values. So each one of those lines, it's a value, it's a property. And the properties will, the values will represent properties of each of those components. So you see here that when I click on a different component, we see several other properties representing to those. So today we will explore a little bit creating a power system or defining a power system or defining the batteries for a Helicopter. If you remember yesterday, we talked about some of the functionalities. And if you remember, we have this breakdown for the functional analysis that, and here we already started defining a little bit the main component. So we have the cabin which will sustain the passengers, and the passengers, we don't have crew. The power, which is the power delivery system. We have the propulsion system here already a bit modeled. I'll go a little bit over it later. A software for controlling the system, and the structure, which will be mainly the structural part for supporting the system and distributing loads. So here we already have the power system. We have the main properties. So for example, a mass and a cost. We created already this property that is a capacity required as the initial guess. So we use that to calculate that capacity requirement required. We are calculating the main thrust that we have, the main idea we have for the cruise, the thrust, the power consumption during cruise. So here you see that this is the power consumption of the cruise and the overall flight duration that we have on the operations here, adding a 30%. So whenever some of those properties, this capacity required will change, but this is just a really high level view of the power system. So let's start creating, for example, a battery for that subsystem and see what kind of battery we need to fulfill or to have that minimum capacity. So for creating components in Valispace, you can either click here to add component to create on the root level. If you want to create directly a child, you can right click on the component and then click on add component. In this case, let's create a battery. And once I create it, you will see that on the tree here, that battery will be added. Let me check one thing. Okay. So you see that when I created this battery, we already have these two properties, cost and mass, And this is because we have a property add by default. And those properties are value types that you can see when you go to your icon here on the user. Under settings, you have the options here for the value types. We have a lot of value types here, but you see that the cost and the mass are, are ticked add by default. So for every new component that you create, you will have those properties added. So you can always add more value types or not. Add more or remove the value types that you want to be added by default. But the value types, the main purpose of that, apart from being added by default, is to support some of the built-in functions that we have. So for example, the sum of children. But before getting into that, let's show just how to create simple properties and how to create simple formulas. So for our battery, we already have cost and mass, which might be interesting for us. We might need to, if we're designing or actually sizing our battery, we might need to define what is the density, the tag specific mass, and also the cost per kilowatt, for example, for a given selection. So for example, let's create here cost per kilowatt hour. We can give a round value here. So for example, for a lithium battery, we have $140 and as the unit here. So we define the unit, so dollars, kilowatt hour. And you see we create this new property that has the content 140. The same thing we can do for example, for the tech specific mass. Oops, wrong place. Which has a constant value. In this case, let's give around 180 watts hour per kilogram. So we can define these baseline values, and later on we can add margins and play around with it. So for a specific property, when you expanded that value, you have a lot of other properties inside the valley. You see here the main name, so the name of the valley and the name of the parent component, the value or the formula that you have, and the value with unit. And here below, you have other interesting properties. So for example, margin, you can add a percentual margin, so plus minus 10%. For example, and Valispace will calculate that, the worst case, including that margin. All right. So apart from that, every change that you do in Valispace, even from the beginning until the end of the project, when you start getting more complex, is stored on the database. So you will have always the full history. So you first, when you create a valley, you have this history graph that shows how that property is evolving over time as your engineers are updating. And you also have below a table that shows every time that someone's modified the value, you have a new entry here saying the time that this change happened, the value before and the value after, and the reason, so who changed what. So to size our battery here, we have, remember that we have defined that capacity required, that is around 35 kilowatt hour. You can see here that I also added tag saying that this is completely, this is an initial guess. We might need to review that and make a proper modeling of that element or of that property, but we can start using that value here for sizing the battery. So now that we have the main parameters, we can calculate, for example, what's the mass of, not here, but here. We can modify the formula of the mass here by taking the energy necessary and the tag specific mass. Specific, sorry about that typo. So if we want to modify a formula, we can just type here, click here on the value, and you see that this is the sum of children formula. I'll go over it later on, but to write any formula the same way on Excel that you would reference to different cells, for example, calculate A1 given B1 multiplies by C1. In Valispace, you can actually make that references by giving the property value, right? So here, for example, if I want to get the mass of the battery, I can calculate the capacity required that we have estimated on the power system multiplied by the tech specific mass. When I modify that, Valispace will calculate that value, which is not correct. Wait a second. It's actually the capacity divided by the tech. That's why. I'm sorry. Like now, that's why that was the warning. I was saying that the unit was wrong because we're actually calculating wrong. But now we have that properly defined. So the estimated mass of our battery will be around 200 kilograms, and we can do again the same thing for the cost. So just to go back there, cost per kilowatt hour, we have around USD per kilowatt hour. And now we can calculate. So for the cost, we have the cost per kilowatt hour multiplied by the capacity required. This one should be okay. Okay, so we have those properties for the battery, and now we can let's say that we want to explore different providers or different types of batteries. This one, I will skip this one because we already lost a lot of time here. So if we want to explore different types of batteries, we can create what we call in Valispace an alternative container. An alternative container is pretty much a template for several options that you can configure in Valispace, and whenever you select a different option, Valispace will recalculate everything accordingly. So we can have this battery as our template. And one best practice that we recommend is that you set up all the properties that you want to have shared between all the alternatives before creating the alternative container. That will save you a lot of steps along the way. So let's assume that we have those properties that we want to have shared between all the possible batteries. We already have that defined. So we can right click on it and then convert to alternative container. Valispace will go through, will have a process and will create this special component here that is called the alternative container with that icon, and we'll add the battery that we had before as one of the alternatives. We can rename that, so well, we can leave it for battery one. And when you click to alternative container, you have this table where you will see all your options. So for now, we have this battery here. And if we want to create another option, we can, for example, copy an existing option. We will copy the battery one and create a second battery. So here I can click to select the battery one, and Valispace will generate that copy. So now we have two alternatives for our analysis. We can change, let's assume that, for example, this battery, let's fix a value here just for an example. Let's say 1000. This battery has a lower tech specific mass, which will actually increase the mass of the battery. But to pay that off, that battery will probably be cheaper. So now I want to go over the sum of children formula that I mentioned. So if you see here on the Valuecopter, we have the property mass, that's sum of children, SOC. And what it does, it goes over every lower level component and calculate and sum up, make the roll up of all that mass. So you can see that cabin, for now, it doesn't have a defined mass. The power system has some, and the propulsion, which is more defined, already has its mass. So what Valispace is doing is rolling up all that mass to the Valicopter. And when we see here in the power, if we go to the battery container, sorry, to the alternative container of the battery, whenever we select a new alternative, Valispace will recalculate the mass of the power system, giving that new mass of our battery. Once it is, now you see that it already updated to 234, and if we change that back to battery 1, the mass will update here, and then all the change will be propagated. One thing to know about the alternative containers is the concept of the shared properties and the local properties, because one specific alternative, they can have their own properties. For example, especially if you're doing completely different concepts, for example, electric engine and a combustion engine, you can create the alternative containers, have efficiency and mass and power, but how you're calculating things internally is exclusive for each one of the alternatives. So if you see that if I create a property here inside the battery one, for example, efficiency, and give some value. If I created that here, it will only be on the battery one component. It's not available on the second, because as I said, this is a internal, it's not a shared property. If you want to share properties between all your alternatives, you can come to you need to come to the alternative container and then come to add property to create a property that will be shared between all your alternatives. So for example, depth of discharge, if we want to create that property and share between all of them, you can either, when you define the formula here or the value, it will be the default value that is created across all, and then you can change that later on. So once I click create, you see that this is already shows on the table, and you need to come to each one of the alternatives and define the proper value. For example, this one might have a bigger one. And you see that you have that properties. Another important thing to know, it's how to reference properties that is the ones referencing or linked to the alternative container. Because when you're writing an equation, as I showed before, when creating a property, so when you use the $sign, you can reference, for example, to the DOD of the battery, but you will see three options here. You see the first option, which is battery.dod, which is the alternative container. And that is the property that will give you the currently selected DOD or the currently selected alternative. If you select any of these ones, you have always the constant value for those properties. So just to show here what I mean, here it's giving 0.7. If I select another one, which still 0, let me change to 0.8. You will see that after this is recalculated, it will update the DOD here of the currently selected property. Okay. Another feature that can be quite helpful for you to understand how your system is impacted by changes is the sensitivity analysis. On each property in Valispace, you have this field here for the sensitivity analysis that allows you to select other dependencies. So any lower level dependency, it doesn't need to be an immediate value. and you see on a graphical way how changing a specific property will impact overall. So when we see the dependency of mass, it's clear that it's a linear value. But for example, if we want to see how changing the specific mass of the battery will impact the Valispace mass, you see that in this case it's not linear. So if we increase or if we decrease the tech specific from 50 to 40, you can see how much you're decreasing on the overall mass of the Valispace.
Kai?
Yep.
Just kind of jump in there because we have a question on our slides.
Yep.
And someone's asked if you could show again how to create the alternative containers in Valispace.
Sure. So for simply create an alternative container, you can select one specific component and then right click to select to create alternative container. So let me see if I can make something specific here. Yeah, let's make, for example, for this screen here, we want to try different types. You can just write to on the right click on the component, and you have the option to convert to the alternative container. And then automatically Valispace will generate that alternative container and move the option that you had as the first option. I hope that explained how to create it. Okay. So how are we on time? Still have a bit more time. So in this case, let me undo that. So if you want to cancel an alternative container, you can always drag and drop a component. So in this case, I'm just making the screen a component of the cabin, and then I'm deleting the alternative container. Just make sure to rename it back to the name you want. And there you have it. Properties in Valispace can also be mode dependent. So for example, here on our Valispace, we have different operating modes, which are off, standby, takeoff, cruise, and landing. And you see that the formula is sum of children because Valispace is going on every lower level and getting the power consumption for each of those elements. The definition of the of the modes you can do here on the modes tab. So for every component, you can define a given mode. So you see that the Valispace has its flight modes defined here. But you still need to have one extra step to define how each element on the lower level is corresponding to my flight mode. So when I'm on standby or takeoff, how is my propulsion system behaving? How is my cabin, my screens behaving? So you do that by making a link with the modes of each subsystem. So here on the linked modes, you see that we have for every column, it is a flight mode of our Valispace. And on the lines, you can define how each subsystem is behaving. So you can always select a new component or a new mode and make that relation. Once you make this relation, you show Valispace how to calculate, for example, the sum of children of each component. So for example, here on the cabin, we can create a AC system, HVAC, 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 yeah. Well, AC. So we have the AC system here. It already comes with cost and mass as I saw on the for the Vali types. We can create the power consumption. Before creating the power consumption, let's create the mode. So our AC mode, in this case, let's just consider or on or off. You can always add much more modes if you want. On and off. And now we can create the power consumption property that will be this mode dependent. So we have a different value for when the AC is on and a different value when the AC is off. So for the name, we can call power consumption. We have already a value type defined for that power consumption. And we can say, switch here to matrix to say that this is actually a mode dependent property. So we can search for the AC modes. When you click it, you have the number of rows and columns defined. The unit is coming from the value type. And once I click create, Valispace will create that property that is a matrix, and you have the different values per mode. So on here, you can give the value for the power consumption for the AC. I have no idea how much an AC system consumes, but probably not 1 kilowatt. But now that we have defined the mode here, we need to define our cabin system also as mode dependent. So our cabin system, we can have here, so for example, let's say just 2 modes as well. Flying, occupied, and empty. So we are assuming that every time that the helicopter is occupied, our screens and our AC and everything will be on. So we can come back here to the power. In this case, we already have a power consumption that was a constant value, and we can make it mode dependent now. So if we click here onto make mode dependent, we can search for the cabin modes, select cabin modes, and Valispace will do that conversion from a simple value to a mode dependent value. And once it's finished, we need to come here to the modes of the helicopter and add that new link. So now we are saying, okay, how is our cabin behaving according to our helicopter modes? So as I mentioned, when it's off, it's empty, but for every other mode, we have our cabin on occupied mode. Once we save that link, Valispace will already calculate, will add the power consumption of the cabin system directly. As we see, we have here the AC power consumption, the cabin power consumption, and we didn't make the link just yet with the AC. So you will always need to make that link between each mode. Now that we saved, this will recalculate and will define the values here. And we have the screen that is 20. Okay, so yeah, we have 10 minutes. I think we can open for questions. I don't know. I don't see if there is any questions there already.
Okay, I think that's good timing, Kawe.
Yep.
Thank you for that, and I hope that was clear to people. I think it makes sense to leave the software up, and then maybe with people's questions, we can answer them directly through a case. There is one question that's coming through our slides, and that was, why does it take some time to see the calculated values on Valispace?
Yeah, so since Valispace is a web platform, the changes that you do, you will send it to, well, Valispace will send that information to Valispace server. The server will recalculate, and then the results will be pushed back to you. So the value will be updated. You have that delay, could be decreased a little bit if you're running it on your own server on premise. But apart from that, we are working recently. We are investing a lot of time on improving the calculations times as well. There is a lot of things that is going on the calculation. It's not, for example, if you compare on a Google Sheet or an Excel, when you change one value, another one is immediately recalculated, but that value doesn't have other properties inside it. It does, because Valispace is doing the unit checking, the margin propagation, the error the requirements verification. So there is a lot of calculation going in the back end, and it's not just a simple mathematical 10 plus 10 equals 20. We're checking a lot of other things, but there is a lot of room for improvement and performance that we are investing time now to make it faster.
And I guess that's something that's a perpetual process
Yeah,
of
of course,
improvement.
of
Yeah.
course.
Well, I hope that clears up that question. There is another question that's come in on our slides, and that is, you mentioned the sensitivity.
Yep.
How does Valispace take into account connectivity?
Yeah, so that sensitivity is a mathematical sensitivity for the talk that I had that I mentioned yesterday. um, I would make the sensitivity and connectivity analysis on a much higher level, not already a numeric or analytical model. Um, so it's not the same sensitivity that I mentioned. It is partially part of the sensitivity, but connectivity is um, it's another analysis that you need to do on the functional part of it. And functional analysis is not a feature that Valispace is approaching yet. We don't have a former method or a former feature for defining or for evaluating functional to executing functional analysis. I'm sorry. Um, even though you can do the function definition of your system as requirements. And when you do the function definition of requirements and you do the assignments and define the parent and children relationship, so here you are defining a little bit of the connectivity, but this is a bigger analysis that you will need to perform on your system.
Okay, I hope that clears that up.
Yep.
But there are no more questions for the time being. So if you would like some of these answered, maybe clarified further,
Yep.
then we do have a few more minutes for you guys to do this now.
Yeah, the time, I can take that couple of minutes also to show the time sequence. The time sequence is a feature. It's a bit more advanced because you already need to have defined your operational modes and all your properties. So for example, the power consumption here, we already have defined. And then on the time sequence, you actually show or calculate how your system is behaving over time. So on the time sequence, you say which modes you're changing. So you start on your system as off, and then we move to takeoff, cruise, landing, and so on. And when you run that time sequence, you can calculate or represent how much power consumption you have over time, and also make recursive, not recursive, um, accumulative calculations. So for example, you have you can calculate the battery state changing over time or propellant consumption changing over time.
All right, there's been another question that's come in on AHA sites, and that is, can you create trade-off results on Valispace? Do you need to go through each parameter separately?
So with the alternative containers, you can, well, you can do this kind of trade-offs when you have the defined alternatives, and you might be able to document that on the analysis, but you would need to go to each parameter. One feature that we have been discussing and we are planning for later is to have actually a sensitivity analysis more generic, that you can select multiple dependencies. And of course, we already have a lot of data to clear up space for us to do optimization later on. But for understanding your trade-off, you might need to go over each parameter and understand how things are being calculated.
We're just gonna give it an extra minute or so in case there's any follow-ups
Yep.
for this, Colin. I mean, if there's anything that you'd want to share in the meantime, feel free. But
Yes,
otherwise, we will just give it another minute.
it's also interesting to know that you can connect Valispace APIs is completely open, so you can connect Valispace with other tools. So, for example, if you plan to have a complete model, flight simulation model on Simulink, you can make that model and use Valispace for the repository of the data. So all the inputs necessary for that simulation, you can connect Valispace with Simulink and then read all that data. Whenever the result is finished, you can push that results back to Valispace. And of course, if that result might impact or might trigger other recalculations of other parameters that were not taken into account on your MATLAB simulation.
Okay, I think that might wrap it up for the question and answer session, as we only have a few minutes left to take us to the top of the hour. Thank you, Kawi, for presenting, and I really hope that people have learned something from this, and there's something to be able to take away from what we've shared today. Now, of course, I'm just gonna go to share my screen quickly, and I'll introduce myself again. But as we mentioned in the past, this webinar will be updated on our website. So if you go to our blog, just like you can see in Valispace Live 1 with the requirements engineering, you will be able to find both videos and the recording for this in the next few days. And what's coming up in Valispace Live 3, we'll be discussing how to do verifications and tests. And it's kind of following on from Valispace Live 1, which was about requirements. And from the last slide, you can see that our webinars about requirements engineering are available on our website if you'd like to view them. And in the second part of Valispace Live 3, we'll be taking a deep dive into the powerful testing module that stands alone in Valispace itself. So just before we end, we shared with you that Valispace is a browser-based tool that offers digital solutions for engineers. And we have a very nice team that is willing to listen to see how we can help review your processes in any way. So if there's anything that you'd like cleared up from today's webinar, or there's more things in general about the world of engineering that you'd like to see a Valispace can fit into, then please drop us an email at solutions@valispace.com, or navigate to the valispace.com website where you can book a free demo and play around with the software yourself. So before we leave, again, I'd like to thank Kawe for his 2 presentations over the past 2 days. And I hope that you guys took something clear from it. I hope we all learned something, and many thanks for coming. I really hope that you have a very productive rest of the week, and I hope to see you all at the next Valispace Live. So thank you, guys.
Thanks, everyone.
Thanks.